Assalamualaikum class, how are you all? I hope you all are fine. We will continue our science lesson. As you know that we were discussing about the concept of gravity and weight in our previous lesson, and you have got all the points by the demonstration of gravity and weight. Gravity is a force by which planet or other body draws object towards its center. Okay, gravity is the force by which atoms stay downward. For example, when I will hold the duster, it is moving towards the downward direction. It is going towards the downward direction only because of the gravity. As gravity is between the earth and object, it is moving in the downward direction. You know that. And one thing more, that is weight. Weight is a measure of heaviness of something. Weight is a measure of heaviness. Measure of heaviness of something, and it is also a force. It's also a force by the things moving towards the downward direction with the help of gravity. Here is the duster. Duster has a weight. It has a weight, and by the heaviness I can observe that it has that extent of the weight. Okay, and in the last we have discussed that weight is equal to mass into gravity, and in the end, in our previous lesson we have done two numericals. You know that numericals are those mathematical questions or word problem in the physics. As you know that we are doing the part of science, that is physics. So we will continue our third numerical, that is a student has a mass of 50 kilogram. Calculate what the student would weigh on the moon where gravity is 1.6 Newton, and for Newton per kilogram. You know that there is a particular format for the solution of numericals. We will first write the data, and in the data we will write about the given and required things. And you know that by the word problem statement, 50 kg, mass of 50 kg, and we have given mass of student, that is 50 kilograms. And next, would weigh on the moon where the gravity is. We have given gravity that is equal to 1.6 Newton per kilogram. And we will write the required things. We can get an idea from the required things by reading the statement. Calculate what the student would weigh. We have to find the weight. So we will first mention required. We have required weight. We don't know the weight. Okay, we will solve this numerical by getting an idea from the required and given things, by the data as well, and we will mention now the solution. In solution, we will solve the statement by the relation that is weight is equal to mass multiplied by gravity. We will write here, as we know, weight is equal to mass into gravity. We will put the values. We will write here putting values. We will continue from the above of the board. As we are putting the values in the relation, we will write weight as it is, and we have to put the value in place of mass. We have given 50 kilogram for mass and 1.6 Newton per kilogram for the gravity. We will multiply 50 with 1.6, 50, 1.6, 6 zeros are 0, 6 5s are 30, 1 0, 0, 1 5s are 5. 3 plus 5, 8, 0 and 0. And you know that it's a mathematical rule. When the decimal point will be written or marked after one digit, we will mention here as it is in the answer, and you will cut the decimal point with 0. As it's a mathematical rule, you know that. And we have obtained 80 in our answer, 80. We have also to solve the units. Okay, kilogram multiply with Newton per kilogram. Newton and per means divide. Newton per kilogram. There are same things in the denominator and numerator. You know that we will cut these same things. Kg will cut with kg, and we have obtained only Newton. So we will write here Newton. It's a unit. So we have answer 80 Newton, and Newton is the unit of weight. It is mandatory to write the unit as well, as it has importance. Then same example, that is a student has a mass of 50 kilogram. Calculate what the student would weigh on Mars, where gravity is equal to 3.7 Newton per kilogram. You know that we will follow the same format. We will first derive the data, and in data we will write the given and required. We have given mass of student, okay, and we have given the gravity, that is 3.7 Newton per kilogram. We have given two things, given mass of student, that is 50 kilogram, and then we have given gravity on Mars, that is 3.7 Newton per kilogram. Data also has second part, that is required. We have to find the weight. So we will write the required thing in the weight. We don't know. So we will solve. We will write here solution. We will continue by writing, as we know the relation, that is weight is equal to mass into gravity. Weight is equal to mass into gravity. We will put values, we will write here, putting values. Weight as it is. In place of mass, we will write 50 kilogram. Multiply gravity, we have given 3.7 Newton per kilogram. We will multiply 50 with 3.7 on the side. 50, 3.7, 7 zeros are 0, 7 fives are 35. 3 zeros are 0, 3 fives are 15. 0, 5 plus 0, 5, 3 plus 5, 8, 1, 8, 5. And you know that when the decimal point is after the 1 digit, we will mention that decimal same as it is in the answer after 1 digit. And when the decimal point is near to 0, that decimal will cut to 0 as well. And we have got the answer, that is 185. We will solve the units kilogram into Newton per kilogram. Kilogram multiplied Newton per kilogram. Kilogram will be cut with that kilogram in the denominator. Okay? Then you will write and here and is Newton, the answer will be 185 Newton, and Newton is the unit of the weight, and we have got answer, that is 185 Newton, weight of the student who is in the Mars. So we will do our next example, that is question number 4. The statement is an exploration robot of 100 kilograms is built on Earth at a place where gravity is 9.8 Newton per kilogram. It is sent to Mars where gravity is 3.7 Newton per kilogram. What does robot will weigh on Earth and Mars? We have to find a weight on Earth as well as on Mars. And you know that we have to use the relation, that is weight is equal to mass into gravity. We will first create a data. In our data, we write two things, given and required, and we have given mass of robot, that is 100 kilogram, and we have given gravity for Earth and mass. At first we are doing the weight in Earth, so we will use the gravity on Earth, that is 9.8 Newton per kilogram. We will write the gravity on Earth, 9.8 Newton per kilogram. Next part of data is required, and we have required weight that we don't know and we have to find. Next step is to find the weight. So we will write here solution. In solution we will write, as we know weight is equal to mass into gravity. We will put values here, putting values. Mass, that is 100 kilogram, and gravity, that is 9.8 Newton per kilogram. 100 will be multiplied with 9.8. 100, 9.8, 8 zeros are 0, 8 zeros 0, 8 ones are 8, yes, and 9 0, 0, 9 0, 0, 9 ones are 9, 9, 8, 0 and 0. And you know that as per mathematical rule, you have to place the decimal point by looking the given digits. Point is after one digit, we will mention here the point after one digit, and when the point is along with 0, then it will be cut. We have got a value that is 980, and we have to solve the units. Same rule, kilogram multiplied with the Newton per kilogram. Kilogram will be cut and we will write only, and that is Newton, 980 Newton. We will follow same method for the solution of mass. As you know, we have given mass of robot. Okay, tell me what will be the mass? 100 kilogram. And next we will use the gravity on Mars, that is 3.7 Newton per kilogram. Gravity on Mars we have given, that is 3.7 Newton per kilogram. Okay, and we have required same thing, that is weight. We don't know the weight, we have to find. So let's move on the solution. We will write here as we know the relation that weight is equal to mass into gravity. Now same method, we will write here putting values. We have given mass, that is 100 kilogram, and gravity, that is 3.7 Newton per kilogram. We will multiply 100 with 3.7. 100, 3.7. 7 zeros are 0, 7 zeros are 0, 7 ones are 7 1 is 7. Okay, 3 zeros are 0, 3 zeros are 0, 3 ones are 3. 3, 7 plus 0, 7, 0 and 0, and the decimal point is after one digit. We will mark here the decimal point after one digit, and when the decimal point is near to 0, then we will cut the decimal point with 0 as well. You know that 370 is our answer. We will solve the units. Kilogram multiplied with Newton per kilogram. Same things on the opposite sides. Its numerator, its denominator will be cut, and we have got, and that is Newton. 370 Newton is the weight on Mars. Start. In this question we had given two things. We have to find weight on Earth and weight on Mars. Robot was an explorer for the different planets. So the calculated mass for robot was 100 kilogram, and there are two things given for the same physical quantity, that is gravity. Gravity on Earth is 9.8 and gravity on Mars is 3.7, and we have calculated the weight on Earth and Mars. We will take a review. We will first write the data, you know that, and data has two parts, given and required. We will first write the given things. We had given mass and gravity. We are doing the question that was on the Mars, so we have chosen the gravity on Mars. Fine. And in required we have to find the weight. Then in solution, you know that we have to use the relation that is weight is equal to mass into gravity. Weight is equal to mass into gravity. Then we put the values. Mass on mass or same, that is 100 kilogram. 100 kilogram, then we write 3.7. We multiply 100 with 3.7 and we have got the answer 370. And after that we have found the units. Kilogram multiply Newton per kilogram, and kilogram will be cut and Newton we have got, and we have found the answer, that is 370 Newton. By the same method we find the weight on other things, on other areas. We just have to know about the relation, that is weight is equal to mass into gravity. And we have done 4 questions. You have to practice these questions in your home. By the same method we can find the weight on any area, on any planet, with the help of the mass and gravity. And when we know about the mass and gravity, we can find weight easily with the help of this relation. As weight is equal to mass into gravity, you should know about the mass and gravity. If you have given, then you can easily find the weight. You have to practice these questions in your home and you have to complete by Monday, and I will check your questions on Monday. If you find any problem, any query regarding this solution of the word problem and numerical, we will further discuss this concept again on Monday, inshallah. Okay, Allah Hafiz.